Hello class and welcome to your next lesson on commercial manufacture. In this lesson we're going to look at how plastics are manufactured in industry and the different methods that are used to get them into their useful shapes. So to start with, I'd just like to revise some of the plastics that we have talked about in the previous materials and manufacturing unit. So plastics can be broken down into thermoplastics and thermosetting plastics, if you remember. Thermosetting plastics are the ones that can be reheated and reshaped many times, so they contain plastic memory, which allows them to return to their original shape when they've been heated. And we've used these in the workshop. We've used acrylic in the workshop for a few projects. The other type of plastic is thermosetting, and these are the opposite. So they cannot be reheated and reshaped many times. Once they have been shaped, they just stay that way. So that's the way they are for the rest of their useful life. Examples of thermoplastics are acrylic, ABS, polypropylene and polystyrene. And some examples of thermosetting plastics, we have urea formaldehyde and melamine formaldehyde. These are the 6 plastic manufacturing methods that we're going to look at, and all of these can be used in the mass manufacture of products, so using the computer-aided manufacture that we talked about in the last lesson. So you'll need to be able to understand these methods and understand how to identify them, and we'll go through that in the next few slides. And what typically happens in your National 5 exam is you could be presented with a product and then asked how it probably was made, how it was manufactured. So that's why it's important to understand. On this slide, where I've named the different manufacturing methods, I've also given you a product to associate with each one, and I find this really useful. What you can do is then compare any product you're asked to identify and see which one of these it might most closely match. So for injection moulding, I think of a complex shape. A good example is the workshop safety glasses. For blow moulding, I would think of plastic water bottles. For rotational moulding, I would think of canoes or kayaks. For extrusion, I think of a ruler, any product that's got the same cross-sectional area throughout. For vacuum forming, think of the inside of a selection box. And for compression moulding, think of the top of a Coke bottle, the screw top of a Coke bottle. So the first commercial plastic process we'll look at in detail is injection moulding, and this is used for thin-walled complex products. Excuse me. And like I say, remember to think of workshop safety glasses as an example. It's a very accurate process for these complex shapes, but the moulds are very expensive. So the process involves heating up the plastic granules, and we can see in the wee hopper here. They're then injected forcefully into the mould, where they set quickly, and we can see that this is a mould with the product set in between. So how can we tell if a product has been injection moulded? Well, here are some of the identifying features that we would ask you to remember. Where the material has been injected into the mould, there's often like a rough mark sticking out. This is referred to as the injection pin mark. Or when it's injected, can be a round dent, and I've shown some examples here on this image. Also, you can see in this image some examples of webbing, these bits that have been added for strength. Other things to look for are a high quality finish and splits where the mould has actually been joined. So these are all identifying features that you could use to see if a product was created from injection moulding or not. So now looking at blow moulding, This is used for whole components in products. And remember I said at the beginning to think of a plastic water bottle as an example for this. The process is quick and cheap, and there's very little waste associated with it. So blow moulding starts off with a parison, which is placed inside the mould. So that's this blue part here that looks a wee bit like a test tube. Once the mould is closed, hot air is pumped down into this and it starts to expand and fill the cavity. So you can see in the image as the air is pumped in, it gets larger and larger until it fills the full mould and it makes the bottle. So identifying features here are splits lines, again where the mould has been taken away, a high quality finish, a uniform thickness throughout the product, and then sometimes there's a small mark and nipple left in the base where it leaves, where it's been held within the mould. So rotational moulding is used for large hollow objects, and this is the simplest of the moulding processes. So plastic powder is weighed out and placed into the mould, and you can follow this on the image shown here. The two halves of the mould are then joined and sealed, shown in this second stage of the image. The mould is then heated from the outside to start to make the plastic powder melt, and it's then rotated on the frame, so it's moved round either here or here, and the melted plastic powder coats the inside of it, and once it's switched off and the heat's removed, it then sets into that shape and the two halves of the mould are separated and you have your moulded hollow shape. So identifying features for this type of manufacture include looking for large hollow plastic products, again mould split lines where the two parts of the mould have been taken away, and a consistent wall thickness, sometimes with thicker parts of plastic around the corners. Moving on to extrusion. This is used to manufacture products with the same cross-section throughout. And the manufacturing process can be compared to squeezing toothpaste out of a tube, but instead of the round nozzle that the toothpaste comes out of, the material is squeezed through something called a die that's shaped as per the intended product. So that could be your U shape or an I shape, looking at the examples on the image there. Extruded products are seldom used without additional processes or forming, so they're typically cut up and then joined to form a finished product. And identifying features for this type of manufacture, the main thing would be looking for long sections with uniform thickness, the same cross-section throughout, and sometimes there appears a line texture on the surface where they've been squeezed through the die. So vacuum forming, this is used with thin sheets of plastic, and it's commonly used to create packaging for things like the inside of selection boxes or advent calendars, or the trays they use in the supermarket bakeries. If you maybe buy like 4 muffins in a pack, for example, they'll be on a vacuum formed clear plastic tray. It can also be used for larger items like a plastic bath. So the process involves heating a thin sheet of plastic, and in the diagram shown on the right hand side you can see this is represented by the blue line. The plastic is heated up and then the mould is pushed up into it. What happens then is the vacuum sucks the air down and out, the air between the plastic and the mould, and what that does is create a really tight fit round the mould as this air is pulled out. So it clings to it really tightly, the vacuum pulls the air out, and once the mould is removed, the sheet is left in the desired shape. So it is suitable for creating complex shapes, and it can be recognised from some of these identifying features. So a thin material, thin sheets of plastic, tapered sides so it can easily be removed from the mould, rounded edges and corners, and sometimes you can see pips in it from the venting holes. So when the vacuum sucks the air out between the mould and the plastic sheet, this is done through just like circular holes in the tool, and that this can leave a mark, so they just have to be placed sort of out of sight on the final product. So our final manufacturing method for plastic we're going to look at is compression moulding, and this is used again for complex shapes, but with thick solid wall thicknesses rather than the thin material that vacuum forming is involved with. So the process requires the plastic to be placed into the mould cavity, and we can see that in the image. I can get my mouse. That's the red colour. So the plastic's placed in here. It's heated up so it then becomes malleable, and the two parts of the mould are then compressed together. So the two parts are squeezed together, compressed together to create the desired shape. This is used to create the tops of Coke bottles and also things like electrical sockets where you plug in your plug in the wall. So identifying features include uniform wall thickness, a really good surface finish, and angled or sloping sides. So rather than a straight right angle, there might be a slight degree of slope on it, and this is so the product can be easily removed from the mould. So, as I said at the beginning of the lesson, you could be asked in the exam to identify how a particular product has been manufactured. So we're going to have a wee go of that as part of our task today. So you're going to use the knowledge gained in the past few slides to say which method you think has been used to commercially manufacture each of these products. And you're also then, as well as stating which manufacturing method you think has been used, I want you to make a wee note of why, like what you're basing that decision on, a bit of a justification. And that's going to help you prepare for your exam. Oh, so maybe just pop back there. So these are on the worksheet that you'll also find uploaded on Show My Homework. So if you can just, you'll see the table on the PDF document. So if you just make a wee note on each of the relevant columns, and then you can either do that electronically and email it to your teacher, or you can just write it down on a notepad or something, take a photograph and then upload that to your teacher, either or. So hope you enjoy the task, and thank you for listening.